All right, thanks for coming out to Star Trek and my session, Giving Clarity to LINQ by Extending Expressions. So today we're going to learn about Entity Framework and LINQ and how those things work under the covers. And then we're going to do some refactoring to get an understanding of what we can use this technology for.
I just wanted to mention the light box.
Gotcha.
Okay. As a focus on lights right there.
So this is my fourth time speaking at Star Trek. I'm very happy to be here. We're going to be watching an amazing movie today. We're watching the Avengers movie. This is the first time in the 4 years that I've been speaking here that they changed the date of the movie being released, and it came out like last week. So I don't know if anybody's seen any spoilers, but you might want to cover your ears. But I heard that Aquaman dies at the end. Just letting you know. If you want to ask questions, we have a Slack channel set up. We're on the yellow channel in Slack. If you're seeing this video recorded on YouTube, if you want to shoot me a question later on, just hit me up on Twitter at one of the hashtags during the slides so I can kind of get a context of where you're asking the question from. So a lot of people don't know that they're actually using expressions when they're using certain frameworks within the .NET ecosystem. So I often ask people at the beginning of the talk if they use expressions and try to get a raise of hands. It's kind of hard to see people in here, so it's kind of hard to ask this question. So it's kind of a loaded question anyways, right? If you're using things like Entity Framework or AutoMapper or some other tools, then you're probably using expressions already. So in the example here on the screen, if we do a where and we pass in this parameter that says where title equals developers, that title equals developers portion of this is an expression, okay? And you can see the signature for this function in Visual Studio, and when you start typing this in, it will tell you this is an expression of a function. If you're using something like AutoMapper, you're using expressions. All of these things that you pass in to build up your mapping is an expression. Even HTML helpers use expressions. So in ASP.NET MVC, when you're using HTML helpers and you write something like this, we're writing expressions so the HTML helper can analyze the code that you're passing in and set up values on your label and things like that. Now, I work for Progress, which is the company that makes Telerik and Kendo UI controls. And we build a lot of HTML helpers for the .NET MVC framework. And one of those is the data grid, and it uses these expressions as well to build up things like columns and features that go into our data grid. So what are expressions? So in C#, expressions are a representation of code. And these allow us to do things like metaprogramming in C#, which enables us to analyze, rewrite, and translate code within C#. Now, there's something in the language that allows us to have this ability. And there's a certain feature of the language called homoiconicity, which means that we have the same representation of our executable code as we do the data representation of our code. So if you look at the two examples on the screen, on line 2, we have a function that takes an integer and returns an integer. And that function is called +1, and we have a lambda expression that says n + 1. So this function will take a parameter and add 1 to it. If you look at line 5, we have an expression of a function that takes an integer and returns an integer, also called +1. If you look at the right-hand assignment, you can see that these two things are written identically. That's homoiconicity, okay? So until we have that assignment, that's when we're deciding whether this is an executable function or this is a representation of that function. So using lambda expressions, like I just showed you in the previous slide, is one way of writing expressions in C#. Go back to that example for a moment. We can say expression of, func of, and then our parameters. The problem with that is we can only do that at design time. If we want to build expressions at runtime, we have to use something called an expression factory. So this is a specialized class that's built into ASP.NET, or sorry, .NET, not just ASP.NET, but .NET in general. And what we can do with the expression factory is we can new up these expressions using this expression factory. Now, we have to use the factory pattern here because we can't call in a new expression of. We have to actually use the extension method, or the methods that are on the expression factory to new these things up. So if we wanted to create an expression at runtime, what we could do is something like this. We could say var expression of constant, and then we could give it another one. We could say, let's define y as an expression of a constant, and these both hold a value of 1. And then we can create a third expression that says expression add x and y, and that builds our expression tree. And we have a binary expression that has two constants of 1. And those two things are being added together in that expression. So if we write this out to the console, we might expect to get 2, but we don't, right? Because this is a data representation of that function. So instead what we get is 1 plus 1. And if we get the type on this data, it is a simple binary expression. Another thing we can do with expressions is we can compile them. Remember, these are data representations that aren't executable. In the previous example I showed you, 1 plus 1 didn't equal 2. It equaled the expression of 1 plus 1. If we wanted to execute that code, we could actually call compile on it and then make it an executable function. So that's something that we can do with expressions. So in this example, we'll call toString, and it'll tell us the data representation of it, and it'll say n lambda n plus 1. If we call compile and then pass it the parameter of 1, then it will give us the output of 2. So what's really cool about all of this stuff is we can do amazing things within the language. We can do runtime modification. And I said at the very beginning I would talk about Entity Framework a little bit. This is the underlying fundamentals of how Entity Framework works. So in Entity Framework, we use something under the hood called an expression visitor that's going to analyze the expressions we pass into our where and select statements. And this expression visitor can traverse and rewrite that code as SQL code. So expression visitors are very powerful, and they're used to traverse expression trees. And it can learn about the expressions, and then we can act upon those things, either rewriting them or coming up with a dynamic code, things like that. Now, the expression visitor is an abstract class. We have to inherit from it and build our own version of it in order to make use of it. So when we're using this class, what we're going to do is override this visit function. And when we override visit, we get to tell the expression visitor what it is we'd like to do. Now, this is the tough part of my presentation for me because I have to do something that no presenter really ever wants to do, right? I have to show you some documentation during my presentation. I'm using the most beautiful screen in the world I can present on to show you msdn.com documentation. So I apologize in advance, but it is worth it. Because I'm going to show you on this beautiful screen one of the most ugly pieces of code. But it's still a very important piece of code, so let's take a look. So what I'm going to do is show you the expression visitor class that you're inheriting from. And that expression visitor class is here on MSDN. If I get the right page. Excuse me, I navigated away from it by accident. Let me grab that URL again. If that's my only demo fail today, I'll be happy. And there we go. So this is the expression visitor class that you're inheriting from and you're implementing your own version of. Now, why it's important to see what the code looks like up here on this nice screen is that we get to see what it looks like under the covers. And what it's doing is when we call visit, it looks at the expression and then it branches off on this gigantic case statement. And what's important about this is you'll see every type of code that you can write inside of this expression visitor. And you'll see things that are very familiar like or else, and if we go to this set of case statements here, you'll notice that all of these resolve to a visit binary method. So any of these that we hit are binary expressions, and then it will call visit binary. And then when it calls visit binary, we can take control of that and do something with it. So let's take a look at what exactly an expression visitor looks like when we build our own and what it's capable of doing. So I've got some code here on .NET Fiddle. If you've ever used a JavaScript fiddler site, this is the same thing, but it's running .NET. So it lets me, in the browser, write some .NET and display some outputs for you. On the first few lines here, I have an expression of a function that takes an integer and returns an integer. You saw me use this before in the slides. This is the +1 method. It's very simple. It takes the parameter of n, adds 1, returns the sum. If I do a console.writeLine on the body of that function, if we take a look at the visual representation of it, I'm looking at the body part of it. So on the body, we have a parameter of n, and then something that is going to add to it, and then we have the constant of 1. So back to our demo, if I call toString on the body, I get the output of n plus 1. Okay? So I'd like to do something a little creative, and I want to create an expression visitor that writes the data out to the console. And what I've done here is I've taken an expression visitor, inherited from it, and now that class is called a console visitor. Its sole purpose is to write the expression out to the console. And you'll see I'm overriding that visit binary, which I showed you is being called from that huge case statement. And when I visit binary, it's going to look at the left and right-hand side of the nodes in that expression. So you can see the left-hand side is this parameter n. The right-hand side is that constant of 1. And then I can execute code on those sides of the expression. So that's what I'm going to do. I'm going to visit the left side, and then I'm going to examine the node type, and I'm going to write that out to the console. And then I'm going to visit the right side, and then I'm going to close this in with parentheses. And if you want to see the left and right visitors, that's these guys here. They just write out the node value. So I'll get my n and my 1 from the left and right side. And then I get my plus and whatever else I might combine these two expressions together with from that visit binary node right there. So in essence, all I've done is recreate the toString method. Big deal, right? What's really awesome about this is I can come in here, and instead of saying plus, I can say add. And notice the output update below. Now I'm writing out n add 1. So how is this helpful? Well, this is the fundamental thing that Entity Framework is doing under the covers when it converts something into SQL query. So when I write something into the where statement, it analyzes that expression I put in, and it grabs things like the parameter name, which usually corresponds to my table, and then the equation of what I'm looking for, converts that into where something equals whatever into SQL query. That gets passed into SQL, and I get my data back. All right, cool stuff. All right. So now we kind of know the fundamentals of all of what Entity Framework does under the covers. Let's look at some examples of what exactly we can do with this. How is this useful? Our Entity Framework already exists. What I know now, I could go write my own provider for Entity Framework. That might be something I need. On that MSDN page I showed you, that links off to documentation on how to do all that. Today I'm going to show you an example of something that I used to refactor a lot of query code out of a large application. So I'm going to use what we know, what we just learned about expressions, to walk you through this refactoring process. And I used it for an application that had many, many, many queries that were very similar, and they had some small differences, and I wanted to abstract things out and make them reusable and readable. So if I ever had to come back and maintain this application, it'd be nice and simple. Now this was an application that was a document repository type of a thing. It held a lot of metadata on documents, and we were able to search those documents. Today I've boiled it down to a simple blog type of application to show you the process. So in an application like that, we might have a query that looks very complex like this. And it's hard to understand here what the intent actually is. There's a lot of parentheses in here, so there's a lot of things being grouped, a lot of order of operations happening, a lot of greater than equals, less than equals. There are some very smart people that can look at this and tell me exactly what's going on right off the top of their head. I am not one of those people. So I need something a little simpler. So I'm going to show you a way that we can refactor this into something that's human readable, and it'll help people that are coming onto the project later to make modifications understand what that code is doing. But before we tackle something complex like that, let's start simple. Let's start with a couple smaller ideas, and then we'll go from there and build upon those ideas. So what's going on here is we're taking our blog posts, and then we're looking for the one that's published, right? Is published, that I can understand. Where a post is published, that's going to be true or false. And then we also have posted on less than or equal to today. So we don't want to publish something that has a date in the future. Easy enough, I can get that. Now before I proceed on with this stuff, I just want to clarify one more thing, and that is there's a distinction here of IQueryable and IEnumerable when you're writing these things. If you write an IEnumerable.where, you're actually passing in a function. If you look at the function signature, it's a function delegate of func of t of bool. It takes a type, returns true or false. If it's IQueryable and you say where, it's a completely different implementation. And it's a completely different signature. It's an expression of a function that takes a type and returns true or false. Okay? So there's one distinction. We're going to be working with IQueryable throughout this exercise. One more thing that some people that use Entity Framework and LINQ don't know is that you can chain together where clauses, and those things end up being and alsos. So in this example, you can see these two pieces of code execute the same way. I can say where some value is 1 and the name is foo, and I can also say where the value is 1, where the value is foo, and chain those things together. They both produce the same SQL query at the end of the day. And this is because of those expressions. And what's really cool about this is we can write them a couple different ways. We can say where, and we can chain them together like this. We could also call the variable name each time and chain them together like this, which is handy if we need to branch in the middle. So we could have an if statement wrapped around one of these and only filter based on some flag in the system. Okay? But at the end of the day, the expression evaluates the same way and the same SQL query is generated. Okay? So the first thing I'm going to do is kind of wrap some of these things up into a custom function it's an extension method. So an extension method basically extends a certain type in the system that we don't already have access to. So on iQueryable, I want to give iQueryable a new function that I can name whatever I want and does a certain filter. So I'm going to go into Visual Studio, and I have an example set up that uses the same code that we showed in the slides, where I've got my repository of posts, and I'm going to pull out where the post is published and is posted before or today or before today. So it's not in the future. And you'll notice I'm also running tests at the bottom. So I'm making sure that when I write new code or I refactor this code out, I'm not breaking anything. Now, the first thing that I want to do is I'm going to write an extension method that's going to take this where, or sorry, actually the first step I want to do is break this into separate where statements. So right now I'm using and also. And to help this be a little bit more readable to me, I'm going to change that to two where statements. And if you're trying to figure out how I just jumped that code ahead, I'm just using get branches. And I'm clicking on the right-hand side here to advance my get branches along. So you guys don't have to watch me type code. It's painful. Trust me. I have to watch myself do it all the time. So the next thing I want to do is write an extension method that takes this where post is published, and I want to just give it a proper name. I want to call it are published. I want to say where posts are published, because that sounds readable to me. And then the next one, I'm going to encapsulate that as well, and I'm going to say this is where posts are they're posted on or before today. So that's the way I want my code to read. And I'll explain how the extension methods work here in a moment. So now I've rewritten the code. I've written some methods that give the code meaning. They're self-documenting. So now my query says, get posts are published on or before today. Very easy to read. I can come into this code and know exactly what it's doing. So I'll scroll down. Oh, sorry, actually, I may have moved these out to another file. Yeah, there we go. So that's another benefit of this. I can move these functions out to another file. So I've moved these functions away, and you can see I am returning an iQueryable of post, and they're extending. When I say this, it's an extension method. I'm extending the thing that will follow it, and I'm extending iQueryable of post. So I'm not just extending iQueryable of T of any type, so this won't show up if it's not a type of post. So it's very specific to this class. So it's an iQueryable of posts, and the posts that I'm extending will become the variable posts, and it's just simply using that method that I had, that where statement that I had before. It's just wrapping it up and giving me a nice name. Okay, so this becomes are published. And then on the second one, I'm actually allowing a variable to be passed in of a date. So I can call that posted on or before, and we can pass a date in and get back the posts that were on or before that date. So fairly straightforward so far, and that gives us some more readable code. So the next thing I want to do, let's compare. So we have this query that's up here that says get all. Let me try to zoom in on this again. I keep getting kicked out of my presentation, but here we are. We could say posts where lambda post is published and also posted less than or equal to today, versus something that I can just read aloud by looking at it and say get posts that are published, posted on or before today. Nice. Let's look at this guy now. Remember, we had this advanced query that we looked at before that had a lot more going on than the previous example that only had two little statements in there. So I'm going to use that same process, and it's going to get us to a certain point. What's nice is that I've already started doing this, and there's things inside of this code that I can recognize and replace already. So I've already written reusable filters that I can come into this pipeline and replace these filters with. So let's jump back into Visual Studio, and I'm going to scroll down to that other code, this other query, And on line 55 here, you can see how long this piece of code is. Okay? Oh. Thank you, PowerPoint. Let's try. There we go. All right, line 55 here, you can see this query is quite long. So if I look at this query, I have post is published again, and I also have this less than. So I can say, in place of this, I can reuse that code I wrote and say r published posted on or before today again. So I'll advance that, and I'll replace those. So now I've broken out two small fragments of that and made it just a little bit simpler. So I can say r published, posted on or before today, and then I kind of get stuck here, okay? There's a reason I stopped, and it's because once I get to this where, I have an and or an or in here. I have an or else in here. Remember I said you can chain indefinitely wheres together and make and also. There's no way to do an or. There just isn't. There's not another operator I can use or another function that I can call that will produce that operator. So I kind of get stuck here, and I'll advance this again, and I try to rewrite this, and I start breaking some things. This won't even compile, because I have something here I want to call on or after, but I can't really do that because of that or statement, and that kind of freezes me up. So what did I learn about expressions that I can reuse that can make me, give me the ability here to write some kind of API that can extend this out and make these things readable and easy to use? So I have a where statement here, and I know what is inside of it if I look at the signature. That is an iQueryable of something, and it's going to take a type and return. It's an expression of a function of something that takes a type, returns true or false. So what I'm going to do next, I'm going to show you a library that I ended up writing to solve this problem. So what I essentially have is in that where statement is I'm passing in this expression. So I know I have an expression. If I could write an extension method that could give me the operators that I want, I could just use those instead. I could have an API kind of wrapped around this where I could just write and or and have an expression visitor go through these expressions and modify those as needed, so I can just write my API however I want. So essentially, I have this Lambda expression that I'm passing in, and if I look at it, it has these components, right? It has a post, it has the Lambda expression, it has a body, and it's got the parameters and things inside of it. What I want to do, if I look at that piece of code I have inside of that where statement, inside those parentheses, within the parameters, I have several expressions. I have this expression of posted on or after, which I've tried to refactor out, and then I have where I'm looking for a featured author, and then I have yet another expression that is looking for some type of cutoff date. So what I want to actually do is write an API that can combine these things together at runtime. And that's what I'm going to show you next. So I've got another project open here. And this is a small piece of APIs that I wrote that is called a predicate extension. So a predicate is a function that returns true or false. I want to extend those things. This is what I'm passing in to my parameter, these expressions that are predicates. And what I'm going to do is I'm going to iterate over the expressions using the expression visitor, and I'm going to take out common pieces of these expressions and glue them back together with and or statements. And at the end of the day, what I'm going to end up with, I'm advancing again, is when I'm inside of my where statement, now I can say things like posted on or after, or, so I don't have to worry about those operators anymore. Now I have an API that says or, And then I can indefinitely chain together things and or, and I can write these rules that I can name with proper human readable names and insert those into my parameters. So now I have posted on or after a cutoff date, or it's a featured author, posted on or after, and I give it the author's name and the cutoff date, and I get that data back. So how is that working, right? How is all of that functionality working inside of that code? And I'll show you the source code to this in a moment. I kind of want to step through it visually first. So I have several of these, and inside of the parameter, I have many of these things together, and I just want to call and or and start splicing these things together with my API rather than with explicit code. So what's going to happen is when my API and or is called, it's going to look at the two expressions that I'm anding or oring together, and it's going to analyze those, and it's going to see that they both have a post parameter, and they're a lambda expression, and it knows that I want to and also these together. So it's going to call an expression visitor, and one of those expression visitor functions is called combine lambdas. So what that's going to do is it's going to take these lambda expressions off. Because we're going to combine these together, we don't need both of them. And then it's going to merge together the post parameter, because we don't need two of those. And then using that expression factory, it's going to bind them back together using an and also. So in real time, it's rewriting this expression at runtime. So what we end up with is a nice API that we can chain together, and when we have an expression, it's extending an expression of a function of t of bool. And I'll show you the source code in a moment here, but what we can do is we can essentially just type and give it an expression, and then just keep chaining indefinitely and ors off of those expressions. We say and, or we can say or. And then let's look at these rules. So if I look at posted on or after, I can simply control click on that, and it will take me to that code. So now I have these nice, concise pieces of query. And you can see the type that the query is returning is an expression of a function of a post that returns a Boolean type. If I look at the code that is chaining those things together with ands and ors, if I go into my predicate extension here, you can see I have an and method. And my and method returns an expression of a function of a type that returns true or false. Okay, now what's different about this extension method versus the previous one I showed you is before I extended an expression of a post, function that took a post and returned true or false. This is actually on any type. So I can use this in any project that iterates over any type of class. So this extends expression of func of t of bool. And the or operator works the same way. The only difference is they call combine lambdas, and they say what type of expression to combine those with. So I'm going to take the left and right hand side of the equation, and I'm going to combine that with an and also. When I call combine lambdas, it strips out all the duplicate parameters that I had from the two expressions, glues them back together, and then returns that. Entity Framework doesn't care, because it's going to analyze the expression, and the expression is exactly the same, it's just built differently. So it's the identical expression being passed into Entity Framework. It creates the exact same SQL query, but now I have a robust API that I can use within my code. So let's take a look at the next set of results. So now I have a file here that I have called post filters, and I'm able to pull out pieces of my code. And I need to undo any changes I have, or source control will bark at me when I try to go to my next branch. Let's advance again. Oh, let me go back. I got one more slide to show first. So now that we've done this, we've refactored that code out into readable bits. Let's look at the before and after again. So before we had lots of operators chaining things together. Now we have something that's human readable. So now we have something that says posts are published, posted on or after today, where the post is on or after a cutoff date, or it's a featured author post on or after a certain date, on or after the featured author cutoff date, to be exact. So what's nice about this is if I need to go in and change any one piece of that query, I can simply go into my code, control-click, and jump to that function that handles that specific piece of query code. And we're actually going to do that because I'm sure nobody's ever had this problem where their stakeholder calls, their boss calls, some new requirement comes in, and now they're like, okay, now we're going to take an array of authors, and that's going to be our featured authors for a certain given time. It can be 2, it could be 4, it could be an indefinite number of authors. So now we're going to have to do some dynamic SQL query. But what's nice is we've already set ourselves up for this, because remember, we can build these queries by chaining things together, and we can put branches in, and we can branch things at runtime. So let's go back again. Let's look at this featured author posted on or after piece of code here. I'm going to control-click, and you can see that this is even broken down further. I have a query called with featured author, and then it's anded together, and it's posted on or after the featured author's cutoff date. So if I look at featured author, I'm just setting it equal to a name. So for all intents and purposes, I just need to iterate over this line of code, which is something I couldn't do when I had this originally all as one big string of statements. Okay? So now I'm able to actually look at this, and I can write a piece of code like this. And I can say, I'm going to set up a new rule, and I'm going to use my predicate extension API, and I'm going to say begin. Now, begin is just a stub method that's going to let me start chaining. Remember, I can't do expression, new expression, and generate a new variable of expression. I have to use the expression builder. So I'm going to kind of short-circuit that by calling this begin method. Now, behind the scenes, begin is actually very simple. If I look at my begin statement just returns an expression of false or true. I can set it to either one. It doesn't really matter. So that will actually satisfy as a basic expression. True is an expression. Once I have true or false, then I can chain on it and or as much as I'd like to build up a query. Inside of the API here, once the final chain is made and it's combined lambdas is called, this true or false gets knocked off the end. So I'm going to look for that in combined lambdas. If I see a random true or false at the beginning, I'm just going to take it out. So my expression visitor cleans up the begin stub. And if for some reason this makes it through to any framework doesn't care what it is. It sees a true or a false, and it doesn't even get passed into a SQL query. So that ends up being a non-op, so we don't have to worry about it. But what I can do is write a piece of code like this. I can say begin, and then I can say for each author in my array of authors, I'm going to add a rule of or featured author posted on or after. So now I can take code I already have, wrap a loop around it, and now I have something like this. And I have a function called featured authors posted on or after that takes an array. And my unit tests are still passing. So I haven't broken anything. And now I have extensible code that's giving me dynamic queries. This is something that's very difficult to do without expressions. There are possible ways to do it, but they usually make you jump through quite a bit of hoops to do it, or they have a lot of overhead. This method isn't for everybody, but it does work. You can generate dynamic queries using this style of branching and using the expressions to build the expression that you're going to pass into Entity Framework. And then there's a little diagram of that starter bit, that little stub function. So it just creates a little Boolean value and then appends to it, and then we just remove that later on. So one last thing that I'm going to do here. So now I have this post filters file here that has all of my query code in it. So the only part of my project now just has this human readable query code. So I have my query statement here, and all of the reusable filter pieces are abstracted into this nice file that's over here. I'm going to do one more refactoring on this. So that one might have been a little hard to see, but essentially, I'll back up. C# 7 and up, they have what is called an expression-bodied member. They've actually been around for a little bit, but they've added quite a bit more in the last release of C# 7. So essentially, what an expression-bodied member is, if I have a piece of code that is only one line, it's only one statement, I don't need to call the return, and I don't need to wrap it in braces. So it's an implicit return. So I can remove the return statement. And now I can just write a lambda expression here. And now that I've showed you how that refactoring is done, I'll undo that for my source control and apply that to all of them. And you can see all of my filters for my queries are just one line of code. So I have a bunch of one-liners that I can go look at when I need to build a query or compose a query or fix something about one of my queries that's happening. And then when I come to my actual query where it's been composed, it's easy to read, it's human readable, and it shows you an exercise of an implementation of expressions in C# and how you can utilize those things in your code, and kind of gives you insight into Entity Framework and what it's doing under the covers. So with that said, if anybody has any questions, I'd be more than happy to take questions and answer them until I'm out of time here. Yes, in the front.
Is there any reason why you used func t bool instead of predicate t?
So the question is, why did I use func t bool instead of predicate? Predicate is kind of a built-in func of whatever that you could use either or, but I don't think there would be a code advantage. You don't see predicate. Sometimes you see action being used as well. Those essentially are the same thing, though. A predicate is just a shorthand version of the same thing. Anybody else? I can select up in the middle, back up here.
When you use your or operator, if you add another filter after that, does that filter get applied to the previous two expressions?
So the question was, when I apply the or operator, does it get applied to that expression or the previous expressions? So your order of operations would matter, and it depends on where in the set of parentheses it would be. It's the same exact thing as if you wrote the literal or operator like this. It executes exactly the same way as the other way would. So you can think of it like that. Hopefully that answered your question. Your order of operations would matter if you have parentheses around stuff, just as it would any other way. So it would only apply, it would apply to the previous, to where you're chaining from. So you would say posted on or after, and that would be or. It would take posted on or after as the first parameter and or it with anything that follows. and I could have multiple things chained inside of this. Okay? Yes?
Just curious, is there a reason you didn't put the rpublished and the posted on it before inside of aware?
So the question was, why didn't I put rpublished and posted on or before inside of the where? Those I chose not to because they, I could have made them into, put them inside of a where statement. These were prior to adding the predicate extension tool. So I guess my advice would be, based on this, if you can get away with just writing simple extension methods, and maybe you don't need this added complexity right here, then I would start by just giving some things simple names. In the scenario I used this predicate extension API for, I had many queries in the application that had a lot of similarities. And a lot of those had or statements that I ran into. If you don't have all of that, and you just want to give some things a simple name, you can just wrap those like that. So it's kind of two different examples, and they're interchangeable. They can be used together. It's just a matter of preference. I'm going to see real quick here, how much time do I have? I'm going to check on the Slack channel, see if 15 minutes, see if we've got any questions in the Slack channel as well. I don't want to leave out any of the other rooms. I've got one, would another structure for or within the expression be handled like where any? I think I might have answered that is the same, it may be the same as the gentleman in the front row asked. It's kind of a matter of preference. You could write them either way. So you could have the where, if they're where, you can have them outside of the chain. If they're ors, you have to have them inside of the expression parameter itself. There's more questions coming in on Slack, but until they're ready, I'll answer a few more.
Have you noticed a difference in performance for where compilation when composing additional expressions together versus just a single expression?
Okay. So the question is there a performance overhead of writing the expressions at runtime rather than writing them as just your normal coded expression at code at time of coding? I haven't done any performance testing myself, but I would imagine there is some overhead. At the end of the day, Entity Framework is still translating those expressions. It's still running through that expression tree. You're potentially doing it one extra time, and I'm not sure what the overhead of that is. C#'s pretty performant at this, but I would say there's got to be some type of overhead involved. But I don't know exactly what the timings would be on that. Let's see, anybody else? Okay, it's hard to see, but I think I've gotten most of the questions answered in here. If anybody, one more, I got one more in front here.
A technical one.
Uh-huh.
Plugin that was doing the images for your lambdas?
Okay, great question, actually. I like to write functional code. One of the fonts that I use, it's just exactly that. So if I go into fonts, you see right here I have a font called FiraCode. This is the Retina version of it, so it's for high DPI. It has something in it called ligatures. So when I'm in, let me go back to one of the earlier expressions here. Let's undo this source control. It's easier to see if I go back into the beginning where I have those complex queries. So when I type something like a lambda, when it sees these two characters near each other, it will give me the actual symbol that belongs there. The same thing with this greater than equal or less than equal to. Essentially, when these two symbols are side by side, it gives me the ligature instead of the two symbols. Yeah, that's called fire code. I really like it. Some people don't care for it. The nice thing is it's on your machine and they don't have to look at it. So it doesn't get checked into source control. Your team doesn't have to put up with it. It's personal to you. Yes?
Somebody type that font name in the Slack.
Oh, the name of the font? Sure, yeah, absolutely. So the question was, can I put that into Slack so everybody can find it? It's called Fira Code. It should be F-I-R-A, and it's on GitHub. So you can actually just do a search for Fira Code. And this GitHub repository is it. You just simply download. You can do download as a zip. And then there will be a list of fonts in there. You unpack those and right-click on them in Windows and hit install, and they'll show up in your system. So I'll paste this in chat. So that's how you get those installed. They also work on Visual Studio Code and other editors as well. So anything that can accept ligatures will display those fonts for you. Okay. Any more questions? We're just about done with time, but I think I can take one more if we have it. Okay. My name's Ed Charbeneau. I'm a software developer advocate for Progress. You might know us as Telerik or Kendo UI as some of our popular brands. You can find my blog at blogs.telerik.com. I'm writing for Progress quite often. I'm a Microsoft MVP. You may see me from time to time on Channel 9. I have some videos up there on functional programming and Angular and web development. Hopefully some more coming soon. I have a podcast called Eat, Sleep, Code. Again, you can find that at blogs.telerik.com or SoundCloud. I can post those in the Slack channel as well. If you have any questions after the event, just hit me up on Twitter or in the Slack channel until it's kind of died down. So thank you, guys. Some additional resources if you guys want to take a picture on the way out. I've written articles about this. The predicate extensions are up on GitHub. You can also install them as a package or the source code as a package if you want to see what the source code looks like.